So what we're doing today is working with quadratic type exponential equations. I mean, that's a mouthful. That sounds like really, really difficult, but it's not. And there's a lot of review of what we did yesterday, okay? So think about what you're actually doing in these problems. You're really just solving equations. I mean, think back to the most early equations that you solved in your life, like this. I mean, back in the day when you learned how to solve equations, when your math teacher suddenly put variables in your math problems, it was like, wait a second, what's going on here? And you went from really simple one step and you elevated it all the way up to like distributive property on both sides and x's on both sides, and oh my gosh, there's fractions. And then we have solved millions of types in years since then, like in all your different math classes. Well, it's just continuing up the varsity math ladder here. You're solving for x here. I want to know what x equals. I want to know what x equals in these. They just look really difficult, but you know, you're learning how to work with these using logs and stuff. And these are quadratic types. So understand the language. Quadratic is where you have an exponent that's a 2. An exponential equation is where there's a variable up in the exponent spot too. So we put those two together and we get something crazy like that. Real quick note, anywhere it says support your answer graphically, that's optional, okay? Like that's just like to kind of check your answers. You'll see that in the homework too. So that's just so you know, you can do that optional, and I'm going to show you that as our last example. Okay, so here we have to solve this problem, and we've got a lot going on, especially in that first term. We're going to use our algebra skills to substitute in something for e to the x. So I'm going to take anywhere it says e to the x in these problems and substitute in a u. And you'll see why as we start working on it. Where u came from, I don't know. That tends to be the variable that's used here. Really, any variable would work, but it's no big deal to use a u, so let's just use it. So you can see in this first term, there's an e to the x. There's also a 2 in there. I'm going to take out the e to the x and replace it with a u, but the 2 is still there. Okay, there's another e to the x. I'll change it to a u. And that suddenly became a really simple quadratic trinomial that we're going to factor. And you'll understand why we're doing this here in a second. So we usually put x and x here. We'll put u and u. And the two numbers that multiply to get -4 and also add or subtract to get -3 would be -4 and 1. Set those equal to 0 and solve. You would get u equals 4, u equals -1, okay? So now that we did the algebra factoring part, let's put back in, let's work in reverse, take those u's out and make them e to the x. So we just temporarily changed their identity, the identity of those first two terms, to make it easier to work with. And now we go back to putting in the e to the x. So wherever u is, I put in e to the x. Okay? Now, we still haven't solved for x. Remember, we're just trying to solve an equation here. X equals blah, blah, blah. All right? So x, these are exponential functions, right? X is up in the exponent spot. So whenever we have to solve an exponential equation, we want to first see if we can get like bases. And if you look, we can't make an e into a 4 or an e into a -1. So that method won't work. The other method we learned is to take the log of both sides. Take the log of both sides is what it's called. So if you remember, we had a problem like, I'll just make one up. Like if I gave you this problem, yesterday we had problems like this, and I said, okay, get like bases first, try that. And you can't make a 3 and a 7 have a like base. So instead, we use this method where you take the log of both sides. What is the base going to be? Whatever this base is. So that's why I chose 3. And then I can put the 3 to the x and the 7 back in. And why did we do that? Is because that cancels, and then using the power property, x comes down on the ground. So that's exactly what we're doing here. Don't let an e bother you. E is a number. we call it a constant. It's just a number like 5 or 2. It's just this number. So instead of trying to write that out, write a rounded number in every problem, we represent this number with an e. So don't let e upset you. And the only other difference is instead of doing a log-base e, we use natural log. It's like a quick button thing. So anytime we have a base of e, we will give both sides natural log. The only difference. So I'm going to do natural log on both sides. Remember, you can do anything you want as long as you do it to both sides. Okay. And so we're at this step here where I can cancel it. Natural log e cancels out because it has a base of e. Remember, natural log e equals 1, log 10 equals 1. Why? Because you know the bases without them being written. So those cancel and they just become 1. All right, so in this problem, natural log e cancels, and now that it's a log problem, if you are a log problem, you can access their properties. And one of the properties is power property. So you can go from the front to an exponent or exponent to the front, and I get x equals natural log 4. That would be the exact answer. We can put it in our calculator, natural log 4, round to 3 places, and that would be one of our solutions. Because it's a quadratic, we typically get 2 solutions, right? So when we do this one, same thing. I have a base of e, so I'll do natural log e to the x equals natural log negative 1. Natural log e cancels, x comes down. Now when I put natural log of negative 1, it even feels uncomfortable writing it. You can't have a negative number there. You guys have seen that. We've talked about it when we checked for extraneous solutions yesterday. That number right there will never be negative. If you forget, though, your calculator will tell you natural log negative 1. It gives you an error. You can never have a negative number for a log or a natural log. You're always going to get an error. It's telling you you can't do that. Okay? So going forward, when you get to this step, you don't even have to show the work. You just say, this is my only solution. Okay? Questions? This is number 1 in the homework, and if you guys ask me to, I'll be happy to do it with you, so we can practice another one together, okay? And get to it. All right. These 2 come from yesterday, but I found that the questions I get the most is how to do these problems, and they're very similar in the beginning, and then they kind of branch off in 2 different directions. So I love that these problems are right next to each other, and we're going to do them together. This problem is also a little bit longer because it has the long factoring in it, but at the end, it's going to be one of the examples I use to show you how to do it in the calculator, and it takes like 30 seconds to do. Okay, so it's kind of a cool example. All right, so what we have here, I mean, there's a lot going on in this problem, right? Lots of logs. There's 3 logs in this problem. There's parentheses and a plus, and what she wants me to solve for x, how the heck am I going to do that? So before you get ahead of yourself, focus on the problem, say, what do I know I can do? And any time in one of these problems you have multiple logs on one side, you need to condense them. You need to make them into a single log. Okay, so you think about your properties. We had power property, which we just talked about. Power property goes out front. We have quotient, where there's division, subtraction, we change it to division, and addition and multiplication. So in a minute, once I do the work, I'm going to have natural log 1 time of whatever these 2 are multiplied together equals natural log, here's the power property, x to the second. So I'm going to go off to the side and multiply 3x minus 2 and x minus 1 and put that answer there. So understand what I'm doing is taking an expanded log and condensing it and making it a single log. It's something we've been doing on the last test. It was on your worksheet on Monday. It's an important skill, as you can see. So I'm just using the space over here because I write so big. So I'm going to do my 3x minus 2 and my x minus 1 and FOIL them out. Right, I just did this times this and this times this, and then combine the two middle terms. Okay, so again, I condensed the left side, applied the power property to the right side. And so here's where we splinter off in these two problems. This is an important moment, okay? How to know what to do next. In this problem, we have logs on both sides. Kind of like that. They cancel. Remember, like when we have the same base, it's like 3 to the something equals 3 to the something, we can cancel the 3's and set the exponents equal to each other. Same idea. When you have logs on both sides, you get to cancel them, and you're just left with this algebraic quadratic to work with. So I notice there's an x squared in here. That means it's a quadratic. That means I can't just solve for x. Like here, you can just set that equal to 0 and solve, right? There's no factor or anything. It's linear. These are linear expressions. This is a quadratic expression. Hi. How are you? Happy New Year.
I'm sorry to interrupt. May I speak to them for just one
Sure,
second?
of course.
Guys, sorry to interrupt you, and you're doing quadratics, which will, please take a moment. I know there's a lot of seniors kind of mixed bag in here, but please take a moment if you are a senior to apply for those Clearwater for youth scholarships. Like Dean's going on an athletic scholarship somewhere. But the bottom line is,
Yes.
Free money is free money. So please apply for that Clearwater for youth scholarship. It's under academic scholarships on our website. The deadline is January 23rd. The application is very short, and there's 35 slots available. 10 of them are literally 2 years free at SPC, and that includes books. So pretty good run. If you're not going to SPC, they'll just give you free cash, pizza money, whatever. Okay. So please, if you are a senior, you've got a little bit of an in being a city school, so please apply. Okay.
And juniors, this is you next year, so
Yep.
keep that in mind.
Yep. Yeah.
Right? Yeah, of course.
Hey, separate question. Do
Yeah.
you have Liz Collins' phone number?
Of course.
Can you send that
Yeah.
to me on email?
Sure.
Thank you. We're moving forward with
Oh, yay. Wonderful.
Trying to
Okay.
get that done before it's awful.
Yeah.
Yes. Yes. Yeah. It's still on our website. You're still tied to Countryside High.
You're still a
Even though you
countryside
go to UCB.
student. Yeah.
Even though I wish you would stay, of course. But,
I
get it.
know.
The bottom line is, yeah, you're still eligible.
She's saying, like, you're talking about early college?
You're talking to early college for your senior
Yeah,
year.
because you still graduate from Countryside High
Yeah,
School.
you still get our diploma. But the bottom line is, they did open it up to all the Pinellas schools, but obviously the Clearwater schools, because it's Clearwater for you, they get the home court payment. You guys, if you're a student athlete or not, it doesn't matter. Dean would get a little bit of a bump because she is a student athlete, but they still give scholarships to kids at different clubs and things like that. Okay?
All
Sorry
right.
to take time this
That's
morning. Thank you so much. If you
yeah,
get a
of course.
shot,
Yeah, I'll send it to you
thank you.
next period. Yeah, sure. Okay, so at this point, I'm going to get all my terms on the same side because we're going to have to factor this, as you might have guessed. And before you factor, you have to have a 0 on the other side. Everybody's got to hang out on one side together. Okay? Now, remember, this is not like the type of factor we just did because there's a number in front of the x squared that's greater than 1. This is where you have to bring down the outside 2 and split the middle. So let's go ahead and bring down the outside 2 terms or use whatever method works for you. And we're going to split the middle into 2 numbers. What 2 numbers? And again, you don't have to make the chart. I'm just really quickly doing it to remind you. We're looking for those numbers, and it would be these numbers. And so -1 and -4, make sure you put an X on them, but it doesn't matter what order you put them in. Now, if you still are not good at this type of factoring, I mean, I didn't say that you liked it. It's okay. I know no one likes it, but you have to know how to do it, okay? So my factoring video is still on Canvas if you need to go back and study that. What? And it is on the PERT. Okay. Did you remember how to do it?
Oh,
Oh, good. All right, so, and then I'm going to pull out the GCF. I'm going to go a little fast here, so spend a little time in here. Don't forget when this term is negative, we factor out a negative. And we should get identical twins in the parentheses, and we do. And then we can write our factored answer, which would be x minus 2 and 2x minus 1 equals 0. So remember, the identical twins get a parentheses and the GCFs. Factored, set them equal to 0, and solve. So I set each of those equal to 0 and solve. Okay, while you're finishing writing that, remember that when we solve a log equation, we always have to check for extraneous solutions. You don't have to show that work. I don't need to see anything. But you have to make sure that if you plug 2 and or 1/2 back into the original equation, that you don't get any zeros or negatives when you plug in. Okay? So you could straight just plug in for each of these. There are 3 places to plug in. Or you could think, okay, I need all the numbers that are greater than 2/3. I need all the numbers that are greater than 1. I need all the numbers that are greater than 0. If you're looking at it this way, however your brain works, go with the biggest number there, which is 1, and 0 in on that. Because we have to be bigger than, our x values have to be bigger than all 3 of those. So seeing if it's bigger than 0 or bigger than 2/3 doesn't mean it's bigger than 1. But if it's greater, if these numbers are greater than 1, we know they're greater than the other 2 numbers. If it helps, you could look at a number line. 0, 2/3, and 2. We would need all the numbers greater than 2. That would cover these numbers as well. So that leaves 1/2 out. You don't have to be negative to be extraneous, guys. Come on, focus. You don't have to be negative to be extraneous. You can be a positive number and still make a negative when you plug in. Okay? So our only solution was 2. All right. This one's a little bit easier. Same beginning. If you have multiple logs on either side, you have to make them single, and we do. Again, with the product property, I'm going to have log base 3 of whatever I multiply those 2 together to get equals 2. So when I multiply x and x minus 8, I get x squared minus 8x. So all I did on this one is exactly the first step as what I did here, which is combine the 2 logs and make a single log. Now what's different, remember I said we branch off right here? What's different in this problem, guys, is that in this one we had logs on both sides. We cancel them. We only have a single log in the whole problem. There's nothing to cancel on both sides. This is the step I keep losing people on. So look, what we have to do here is rewrite our log in another form. It's other form. You start with the base to the power on the other side equals all of that. 3 squared equals x squared minus 8x. But I just keep writing it like this, and I think that might be what's confusing people. Either way, it doesn't matter. Right, 3 squared is 9. I just flipped it. I just like to have the x on the left-hand side, but it's not required. And we're at the same step as we were in green over here. Get everybody on one side. So I'm going to subtract 9 and factor. But this is the faster factoring problem, right? So I would get x minus 9 and x plus 1 and solve. Now, go back up to our problem. Can I plug a -1 in where this x is? Nope. Can I plug it in here? Who cares? If it doesn't work in one of them, can't keep it. If I plug a 9 in, I wrote over, is that minus 8 right there? Yeah. So 9 minus 8, fine. 9 there. There is our only solution. Okay? 11 and 12, I would star those. Those are the 2 problems that people are having the most trouble with. Like, how do I know what to do? Okay? And that's a great way of saying it. All right. one more example, then I'll show you on the calculator. This next example is so easy, though. You've seen it before. And that's part A on number 13. Guys, we're back to the PERT formula. This is the compounding continuously. You've deposited $1,000. There's your P. Interest rate, R. Compounded continuously makes it a PERT problem. Guys, stop talking. You can find the balance in your account using the PERT formula, but they plugged everything in for us. Look, there's the P, there's the R, percent change to a decimal. The question is, use this formula to find T, time, for the balance in your account to double. So A of T is how much do I have in my account after T number of years. So doubling 1,000. So I put 1,000 in. My question is, how long will it take to double it? So doubling 1,000 is 2,000. So our variable here is T. Remember, E is not a variable. I mean, it technically is a letter, but it represents a known value. We know what E is. It's T that we're solving for. Okay? So you had this same exact problem before we learned logs. And I actually love this moment every time I teach these types of problems every year, because before you learned how to do logs, it would have been a multiple choice question, and you would have had to plug and chug. Keep plugging in the values until you get as close as you can to 2,000. Okay? And now that we know how to solve using logs, that's what we're going to use. So remember, whenever you're solving an exponential equation, this is exponential, so I've got a variable up in the sky. You need to get your base by itself. This 1,000 is hanging out, and it shouldn't be. The base is E, so we need to move this 1,000 to the other side by dividing both sides by 1,000. You don't have to show that work. 2,000 divided by 1,000 is 2. And now I want to get T down on the ground. I want to solve for that variable. And a way of doing that is using logs. This is just like this problem right here. How did we get the x down on the ground? We took the natural log of both sides. Why natural log instead of log? Because it's a base E. We'll have natural log 2 equals natural log e to the 0.065t. Natural log e cancels, and now that we're a log, we can use the property of logs, the power property that puts this back down. See how we can use logs to bring a variable out of the sky down to the ground? That's what we just did. And then t would equal, I'm just dividing both sides by this number. And then we can put it in our calculator to see how many years. Just be careful, guys. Natural log 2, you either have to close your parentheses or hit enter. Okay? Divided by 0.065, and it didn't tell us what to round to, so let's just stick with our, whatever it's called, 4 decimal places. So 10.664 years. Okay. So logs are a really great way of bringing variables out of the exponent spot. All right, we're now finally to the moment you've been waiting for, and that is to how to find these on your calculator. You can do any of these problems, get the answer like that. So on our last page, and I want to tell you, and the reason I'm going to use one of these, we'll just do this one, is in the homework, the problem looks just like this. She wants us to do a whole table and all this stuff. Don't worry about it. All you're going to do is, in the homework for the 2 problems, is exactly what we're doing right here, which is find the answer. What is x? Solve it without doing any work. Okay? So pick up your calculators, clear your RAM, pay attention, easy. What I'm going to do is find the intersection of the 2 sides of the equation. So you're going to go to your y equals, and you're going to type each of these in as y sub 1 and y sub 2. So remember where your e to the power is. It's above natural log. E to the power of 2x. There's my y sub 1. Arrow down and put in the 60. Then what would I hit? graph. Now remember, to find the intersection, I need to see the intersection. It has to be on my screen somewhere. It doesn't have to be any particular place, but I have to have a little bit of room around it. I don't see it, but that should make sense. Remember, our window defaults to 10 in every direction, and we already know that y equals 60 is a horizontal line way up at 60. So we have to go above 60 to be able to see that intersection. So go to your window, put in, I don't know, 100, whatever. Is that negotiable? Yes. That is not the only number you need to put there. Because as long as you can see the intersection on your screen, you are good. And there it is. So we go to Calc, Intersect. And remember, we use our left and right keys only. And I can see my cursor down there at 0. So I'm using my right arrow. Any place that you see my cursor, I can hit enter at any point for my first curve. So there. And remember, it always jumps to the horizontal line. You can go to the left or the right of your intersection. So you can go left or right at this point. It doesn't matter. And it doesn't matter really how far away. It's a very general thing. It's very loose, which is nice. Yes? Yes, please. And we get x equals 2.047. That is the solution. If you used natural log of both sides and did all the steps, that's what you would have gotten as your answer. Okay? So last thing I'm going to do is prove to you how valuable this is by doing this one on my calculator. If you want to just watch, that's fine. So if I do this right, I should get x equals 2 as my solution, right? So I cleared my RAM, and I'm going to type this in. So 3, so if you just want to watch real quick. Oops, minus 2, plus, natural log, oh shoot, Tracy. That's going to mess up. Dang it. See what happens when I try to rush? 3x minus 2 plus natural log x minus 1. Okay, and then the other one is 2 natural log x. Okay, so graph it. And intersection is kind of jumbled in there, but that's how much it doesn't matter. I don't need to even change my window here because I can see where the intersection is. So second, calc, intersect, and find my cursor. Where are you? There she is. Okay, so maybe I might do there and there. Look how loose I'm doing it. I'm not even really looking at it. X equals 2. So think about all that work, and you can check your answer and get x equals 2. Pretty cool, huh? I'll save this. Okay. Question on the calculator? Okay. So we're on practice set 2. Go ahead and write the problem down. Does anybody want me to do the first one? I will. Be happy to. All right. I'm going to go ahead right off the bat and move the 42 over. Because I know I'm dealing with a quadratic, and on a quadratic, all terms have to be on the same side. So it's not night time, it's time to do homework. And these weird-looking problems is where I say, I'm going to make e to the x equal u. And then I'm going to go back in, and anywhere I see an e to the x, I will make it a u. Factor. I didn't lie to you when I told you we'd factor all the time in this class. you talk to any of your Algebra 2 friends thinking of taking this class, make sure you tell them they have to have that there. But don't scare them away just because of that. I do teach it again at the beginning of the year. Okay, so what numbers multiply to get negative 42, add to get negative 1, negative 7, positive 6. Yep, thank you, Steve. Set them equal to 0, solve. And this is the moment we go back in and switch back in to our e to the x. I think it's just such a nice little trick. Remember, anytime you have a negative here, it's going to be extraneous. We're only going to get our one solution from this one. Base of e, we take natural log of both sides. Bring the x down, that guy cancels. Exact answer. Approximated answer. It looked really hard in the beginning, but it really isn't, right? The hardest part is by factoring. Any questions on number 1 before I put the rest of the key up for you? And number 5 is like example 11. No, example 12. Example 12. Number 5 is like example. They don't teach us how to do this in teacher school. Wait. Let's work together, help each other, make friends. Literally everything. Your favorite color is brown, they're in scholarship. I took a couple of courses at SPC over the last 2 years. I was learning sign language, and then I took calculus just to take it, and I got a scholarship. I mean, I'm a professional teacher and make a decent living. They gave me, I didn't even pay for any of my classes like the first year. Yeah. There was like a COVID thing, like all of a sudden there was $1,500 in my account. My class only cost like $500 that semester. I was taking sign language, and they put $1,500 in my account. They're like, this is for COVID. I'm like, okay, thanks. At SPC, yeah. They know I'm a teacher and everything. And I was not even degree seeking. I was just taking classes for fun. Just to learn. What was he calling you? Because I want to call you a nickname. Oh gosh, I forgot about that.